Dark matter could be primordial black holes that were formed right after the universe was born. Despite its prevalence in the cosmos, dark matter is mysterious, albeit astronomers know that it does not emit light and not composed of atoms, as well as electrons and photons. It also makes up 84% of matter in the universe, with much of it located in halos around galaxies. Primordial black holes. Black holes are often formed with the explosive death of massive stars, a process that can take hundreds of millions of years. Some black holes are thought to exist in the early universe, but there is likely not enough time for these objects to go through the normal formation process. Scientists have suggested that these early black holes may have formed through alternative processes such as those linked to the direct collapse of primordial gas and cosmic inflation. There were early suggestions that dark matter is composed of primordial black holes, which were formed in the universe's first fraction of a second. LIGO's detection of gravitational waves from mergers of black holes have rekindled interest on the idea that dark matter are composed of primordial black holes. Depending on the mechanism at work, primordial black holes could have properties very similar to what LIGO detected, NASA astrophysicist Alexander Kashlinsky earlier said. If we assume this is the case, that LIGO caught a merger of black holes formed in the early universe, we can look at the consequences this has on our understanding of how the cosmos ultimately evolved. Researchers suggested that primordial black holes of tens of solar masses could be considered as dark matter candidates. Stellar distribution in dwarf galaxies. In a new study, astronomer Kerong Ju, from the Harvard-Smithsonian Center for Astrophysics, and colleagues ran computer simulations to find out if they can find signs of primordial black holes in dwarf galaxy halos and found that they could. The researchers suggested that looking at the stars in faint dwarf galaxies can test the PBH dark matter hypothesis. Interactions between stars and primordial halo black holes may have slight effect on stellar distributions. Galaxy halos that are made of black holes should have different density distribution compared with halos made of exotic particles. Black hole halos should have also formed early in the evolution of the galaxy than other halos. Using the observed half-light radius and velocity dispersion of stars in the compact ultrafaint dwarf galaxies as joint constraints, we infer that these dwarfs may have a core dark matter halo, the researchers wrote.